Hi students, I'm Teacher Maine Bernales and I am here to help you understand the lesson for Week 3 Mathematics 9. The most essential learning competency for Week 3 is solving equation transformable to quadratic equations, including rational algebraic equations. We have the objectives. These are transform rational equations into quadratic equations and solving equations transformable to quadratic equations, and last one, perform the task with self-confidence. Okay, so for the first example, we have the given the quantity of 2r plus 3 squared plus the quantity of r plus 4 squared equals 10. So we're going to transform the given equation into the form ax squared plus bx plus c equals 0. So to transform this, we're going to expand the given square of binomial. We just have to rewrite 2r plus 3 and another 2r plus 3 plus the quantity of r plus 4 times the quantity of r plus 4 equals 10. So we're done expanding. Next is apply the distributive property of equality. Multiply 2r and 2r. The result is 4r squared. 2r times 3, the result is 6r. 3 times 2, we have 6r. And 3 times 3, the result is 9. Now, the second pair of binomial, we have to multiply r times r. We have r squared. Next is r times 4. So the result is 4r. Also have to multiply 4 times r, which is 4r. And the two last terms, 4 times 4, which is 16, equals 10. So after that, we're going to simplify the equation by combining like terms. We have 4r squared and r squared in here. So the sum is 5r squared. Next, we have 6r plus 6r is 12r. 12r plus 4r is 16r. 16r plus 4r is 20r. So we have to write here 20r. And then we also have 9 plus 16, which is 25, equals 10. So we have to write everything or all terms on the left side of the equation. So we have here 5r squared plus 20r plus 25 minus 10 equals 0. Still, we need to simplify it. We have 5r squared plus 20r plus 15 equals 0. So as you can see from the given equation here, we were able to transform this or derive it from to quadratic equation in the form ax squared plus bx plus c equals 0. Now, we're going to solve for the roots of this equation. You can use different methods. We have like extracting the square roots. We also have factoring, completing the square method, and the quadratic formula. So let us check if this given equation is factorable. So we have 5r squared plus 20r plus 15 equals 0. As you notice, we have here common factor, which is 5. So we're gonna remove the common factor by dividing the equation by 5. So this will become r squared plus 4r plus 3 equals 0. So I guess it's factorable. Let's continue. We have 5 times, we have to allot 2 pairs of parentheses for the factors of r squared plus 4r plus 3. So now, we're going to look for the factors of 3 since ang ating a ay, dito ay 1. the value for A is 1, and we have C which is 3. So A times C, which is 1 times 3 equals 3. So we're going to look for the factors of 3 whose sum is 4. And that is 3 and 1. So since 3 and 1 ang factors, we just have to write R on both the first term of these two pairs of parentheses, no? Kasi we're expressing it as product of two binomials. So the factors are 3 and positive 1. So we're going to write R on both the pairs of parentheses as our first term. Kasi once we multiply that, that will become R squared. And that matches our quadratic term. Okay? So we just have to write 3 and 1, since they are all positive. Just have to copy the sign. Okay? Now, to solve for the roots, we're going to separate these two terms. So we have 5 times the quantity of R plus 3 equals 0. And the other one is R plus 1 equals 0. Applying the zero product property. When we say zero product property, it's either A is 0, this first binomial is 0, or the second binomial, or both of them are equal to 0. Okay, so let's continue. Once we divide the equation by 5, to eliminate this, let's solve the linear equation now. We can also distribute this 5. 1. So that will become 5R plus 15 equals 0. Or we have 5R equals negative 15. Divide the equation by 5. The answer is negative 3. Well, on the other side, we have R equals negative 1 as the answer. Meaning to say the roots are negative 3 and negative 3 or negative 1. So we can also check our answer if that is correct by substituting these values in our original equation here. If it satisfies the given equation, then our answers are correct. Okay? Let's have the conclusion. Therefore, the roots are negative 3 or negative 1. So this is how we transform and solve equations, transformable to quadratic equations. I hope I was able to help you in this lesson. For another example, including rational algebraic equations, you may watch the second part of this tutorial video. See you there. Thank you for watching.